Computing. I'm going to be demonstrating Genesis AI Enterprise Data Agents today. You can find more about this on our website at genesiscomputing.ai. You can find all kinds of information. I'm going to go ahead and give you a demo. I'll be demonstrating today from an installation from the Snowflake Data Marketplace. If you are using Snowflake, you can search for Genesis on the Snowflake Marketplace, press the Get button, and install this into your Snowflake account. It's also pip installable. You can reach our GitHub from genesiscomputing.ai as well. So I'm going to be showing a classical data engineering source-to-target mapping project with a data agent working on this together with a team of human data engineers. The starting point is going to be a desired source-to-target mapping spreadsheet. We could also support Jira, other kinds of project management systems, but we find that people oftentimes are still using spreadsheets for this, where they capture the desired tables that they want to be created, the columns they want in those tables. Agents are also good at helping to figure that out if you're not sure what columns and tables to create, but in this case we already know. And then at this stage there'll be a requirement specified for each column, which is here in English in this column description column, where we can see just an English statement of what kind of data is desired to be in that particular column. Some of these we have the desired type of data, length of the string, for example, and in some cases we have a list of potentially valid fields that go into those columns. Also here in this case we're actually running a past project, one that's already done by humans, and in this case we have a column representing the correct mapping in terms of the source to target and any transformations required. When the agents work on this, that column will not be given to them in advance, of course, but they'll keep that in a little sealed envelope and be able to open it up after they've proposed a source-to-target mapping to be able to self-evaluate and see how good a job they did in terms of being able to identify the correct sources, the correct mappings, and correct targets. So this is the starting point, and what the agents do is then they kick off a project. So you can chat with an agent, or you can give it a project to work on a variety of ways. Here we've already done that, and the agent has already read that spreadsheet and started to build up a list of to-dos that it's going to work on. In this case, it's created one to-do item within its mapping project, for each of the fields it needs to work on. It's going to do work on each of these fields. You can see some of these it's working on still with the hourglasses, some of it's done with the green check marks. The agents work autonomously behind the scenes to perform this work. We can go and check on the status of the agent's work on any of these fields by clicking on this little button. We can see the description of the work and then the log of what the agents have done so far as they've done this work. For example, in this case, the agent did a source-to-target mapping proposal, then it evaluated it by opening that little sealed envelope, as I mentioned, and then it updated that Google Sheet, the same one that I was showing you a second ago, with its results. So we could either go in here to look at what it did, or we can go back to the Google Sheet because the agent has put what it did in the Google Sheet as well. And I'll actually look at two fields that it's worked on already. The first will be primary diagnosis. This is obviously synthetic healthcare data we're showing you here today. So the goal of this column was to get the primary main diagnosis extracted from the diagnosis codes array. That's what the human entered requirement was. And so if we scroll to the right a little bit, we start to see what the agent has done. So the agent has filled in these fields starting with column L. For example, in primary diagnosis, it does a series of steps. So the agent actually is not just one AI agent, but it's broken down the work into a series of AI agents that work together and delegate work to each other, each of them being a specialist in a particular type of this analysis. And the first first kind of sub-agent is called the source researcher agent. And what that agent has done is it's gone through and it's explored the potential sources. In this case, we're actually starting from a data lake, which happens to be stored in a Databricks Delta Lake format. Here, just in Databricks briefly, I can show you the data. This is kind of just the raw source data stored in this data catalog inside Data Lake in Databricks. The source data could already be in Snowflake. It could be anywhere. The agents are able to connect from the instance running in Snowflake to other systems where needed to find and root out source data. In this case, it actually searched for and connected to Databricks to do that. It found some tables, claims table in the bronze layer in Databricks, claims detail table, and then some other related potential tables. And what it's done here is it's written up basically a report about this column, primary diagnosis, and all the work that it's done to explore where to potentially find data that relates to this desired target column, the potential sources from one or more, in this case, back-end source platforms. And then it's also searched a set of historically legacy documents. So the agents can understand not only the schemas of the source systems, but also hundreds, thousands, whatever, of documents. And documents could be PDFs, they could be past project mapping documents, it could be DBT extracts, it could be legacy Informatica extracts, or views from old HANA systems or something like that. And the agents are able to, they index all that information, and then they can search across it when they're trying to do research about particular, in this case, source to target mapping or anything else they're doing. And here it actually found a old Informatica project, an extract from it, that gave it some insight into how diagnosis codes have been mapped historically in a legacy system. It found parts of the document. So in any case, it's concluded. This is the source research. So every field, it writes up a full report about it. It does this very, very quickly, much faster than a human would do it, and much more detailed than a human probably should do it. But writing up these detailed reports we find is very useful for the agents to communicate amongst each other, and also to really help them understand what they're doing. The next thing it does is it decides whether or not, based on the source research, it's confident enough to propose a mapping. There's kind of two potentials there. Either in this case, it is confident enough to propose a mapping, and then it goes ahead and proposes it, and another agent kicks in, the mapping description agent, and the agent reads the work that the first agent did, the source researcher, and then writes up a proposed source to target mapping, include the sources, where to get it from, any required business transformation logic, a detailed and footnoted justification of why it thinks this is correct, not only where the stuff is, but why it thinks it's relevant to the requirement and why it thinks it's correct. And then it proposes us a SQL snippet for this particular field, which of course then get consolidated together with all the other fields to turn into, we'll be using DBT here and do a DBT mapping. So the mapping has been proposed, a full little document has been written about that mapping. We don't expect humans to ever read these documents really, unless they're demoing like I'm doing now, or they're trying to understand more details about what is going on. And then they break that out and they put it into structured data as well. So here we have the upstream connection with Databricks, what table it's coming from, what column it's coming from, and then a description of the transformation logic in this case. And it says that's ready for review. It's also here done the evaluation. If I scroll farther right, we can see that it did evaluate by opening that little envelope to see whether or not the mapping was actually correct. In this case, it was true, and it writes a little explanation of why that was the case. So another one, it did claim status. It also did a different column. It also did source research on that column. But in this case, it was not confident enough. It said, I'm not confident enough to propose a mapping, explained why, and then it wrote a set of clarifying questions. And those questions can then be proposed or read by a human, questions posed. And I can see those questions here. And a human can then answer these questions, very specific questions, by filling in this cell here. And if they do that, the agent will reopen this work. It'll review the answers from the human, and it will proceed, most of the cases, to actually propose a mapping, assuming the answers kind of make it then confident enough. So having this human kind of input when needed is very, very useful to this kind of process. So it goes through all of that work, and then it puts all the results into its memory and also updated that spreadsheet. And then once it's done the work for all these fields, a second agent kicks in. In this case, since we want to use DBT to actually do the transformation, however, the data was not yet in Snowflake, it was in the data lake. There's going to be another agent that kicks in here that's going to start to actually connect the data from the data lake into Snowflake. And what this agent has done is it's read that spreadsheet and determined what fields are required from what tables on that system. And then it's gone through and actually mounted the data using Iceberg from the data lake to Snowflake. So here you can see a little bit of the details. It's identified the source tables from the spreadsheet, from the work the other agents did. It mounts those tables from the data lake as Iceberg tables in Snowflake. It verifies the mounting is correct. And then it queries both Databricks directly and then the mounted on Snowflake, and it validates that the row counts are the same on these systems to make sure it mounted it correctly. So that's a whole kind of a different kind of work the agent has done here in order to get it set up for the third step, which is going to be where it can actually go and do the data engineering work required. I'll show you that with the third agent here, which is the DBT engineering agent, which will bring this home and actually it'll write and run and debug DBT mappings to actually source the data from the identified sources, transform it as required, and then target it into a gold layer schema. And we can see here, if we open the thread here, we can see how this agent did that work. You can see this is the PM agent talking to the DBT agent. They talk to each other. We can see the agent's planning on doing is getting the requirements, preparing the project, generating the DBT models, running the models, verifying the results, and then logging the results. You can see under the hood here, it's going to do that. So it's found an existing project. We told it here to actually recreate it in that case, which it did. So it's actually jockeying DBT directly. The agent is working with the DBT as a tool. It's created the project, then it's written 3 DBT models and added them to DBT. It ran into a little glitch here, which it self-solved in terms of a parameter for that. Then it ran it. It determined that there was actually an error in the model. There's an ambiguous column name because it didn't provide a prefix properly. So it figured out how to resolve that. It found we got another little issue that it resolved. There's lots of times the agents are able to really solve their own problems. And so here it went ahead and ran that. Then it successfully ran the DBT model after it fixed the various these issues it resolved. Then it went and it tried to verify that by reading the kind of tables that were created to see what they look like. And it realized it had forgotten to do a step of granting access back to itself, basically back to the agents. So it fixed that. And then it was able to see and validate that the resulting tables look correct. And if we as humans go in here into Snowflake, we can see, by the way, these are the mounted data iceberg tables that we started with. And you can see the iceberg thing that this was all set up by that second agent I showed. And then we can go into the gold schema here, and we can see this is the table that the agents decided on the structure of, and then identified the columns for it, and then we can see the actual rendered data that is the result of this source to target mapping. So that was an example of a set of data agents working together in Genesis to take requirements specified by a human user, figure out where to source the data from, how to transform it, and then actually put it into the correct source tables using a whole variety of tools underneath the covers, including, in this case, DBT. Could be other things other than DBT, but that's something a lot of our customers are using. So if you're interested in learning more about how this works or trying it on your own source target mappings or other kinds of data engineering or data operations use cases, please contact us, and we'd love to explore that with you. Thank you.